Today I'm going to make a tool cart with casters that deploy with ease. When the cart is where I want it, I simply push the lever again and the casters retract out of the way, leaving a super stable surface to work on. There's also tons of built-in storage where everything is organized to improve my workflow, and I solve some of my dust collection problems. But before working on the lifting mechanism, organization, and dust collection, I have to build the cabinet. And I'm able to quickly break down these pieces using my portable MFT workbench and track saw. For now, everything is cut oversized just so the pieces are more manageable to work with. It's easier for me to rip the parts to final with the table saw when they're shorter. Then back at the MFT, I square up one end, then flip the piece over and bring everything to final length using my little 3D printed flip stop on the fence. This little guy makes this process super quick and accurate on multiple parts. Then I adjust it to cut the rest of the parts, which are 2 sides, a bottom, back, center divider, and 4 stretchers. I designed this tool cart to have inset draws, so the front edges of all the plywood pieces will be showing. I made sure to cut all these parts about a 1/4 inch narrower than I actually needed, so I could glue on 1/4 inch hardwood edge banding. I actually probably should have done this step before cutting to final length, but it was still easy to do at this point, and it's always a fun day when I get to use the pop-up dogs on my bench. All right, to join these parts together, I'll use 3 different methods of joinery. The back and bottom will simply be screwed to the center divider through countersunk holes. The stretchers will connect to the center divider and side panels using pocket holes, and the side panels will be attached to the back and bottom using dominoes, the trifecta of easy joinery methods. Order of operation when assembling this is key. First up, the center divider gets screwed to the back panel. To make sure it's perfectly centered, I clamp the stretchers to the panel to use as spacers. Then I clamp the divider down and locked it in position with screws. Next up, that assembly gets attached to the bottom panel. Same situation as before, I want to make sure the center divider is perfectly centered. So I clamp the stretchers on the board to use the spacers again and screw it all down. Now it's time for the side panels. Dominoes get glued into the sides, then they're glued and clamped to the back and bottom. Some people use pocket holes as clamps in a situation like this, but I had time to wait and let the glue dry. Last up, the top stretchers are screwed in place through pocket holes from the top. Notice how I offset the holes by the center divider so the screws won't run into each other. And I also made sure to set the front ones back about a 1/4 inch or so to make room for the draw pull hardware I'm going to use later. Super easy, main cabinet is done. Moving on to the base, which I'll make using the scrap left over from my main workbench build. I cut the feet to size using a stop block at the miter saw and almost destroy my laptop when looking for material for the stretchers. That was a close one. I cut the stretchers to length and stared at it for about 20 minutes to figure out what the next steps are. Okay, got it. This base will attach to the cabinet with screws through counterbore holes. So the first thing I'll do is mark out those hole locations, making sure to avoid any part of the cabinet where screws are already in place. I mark the depth that the counterbore holes need to be to avoid the screw poking through the bottom, and drill out all those holes at the drill press using a Forstner bit. And then I drill smaller holes to fit the screws all the way through the material. I'll use dominoes to connect the stretchers to the legs, so I mark out all those locations, make all the mortises in both the stretchers and the legs, then glue it all up. I start by assembling both of the short sides individually. Then I forgot to press record when I glued the long stretchers that attach both of those short sides, but I'm sure you can imagine how that process went. Anyway, I clamped the base to the cabinet and locked the 2 parts together with screws through the holes I drilled out before assembly, and the main cabinet is done. Time for the casters. These are the new R8 smart casters from Bennington Manufacturing, and they're so cool. You'll see how they work in a bit, but installing them is pretty easy. You just have to screw them to the leg of each bench, but I had a slight issue where I couldn't reach the inside holes with my drill because I mounted these too close to the stretchers, so I used a ratchet with a bit to tighten the screws in that tight space. A better solution for that would have been to install corner brackets by all the legs. Then I could easily reach all the mounting holes with my drill, and if I would have read the installation instructions all the way through before building my base, I would have seen that pictured pretty clearly. But here we are. I just worked with what I had already going on, and here is the magic of these casters. After installing, you remove a screw that's holding them in place, and they're free to deploy and retract. You can see every time I pull up on the caster, it changes its position. When your workbench or cabinet is right side up, all you have to do is lift up on each side individually to retract the casters, and your cabinet is back on solid ground. If you want to move it around again, just lift up each side to deploy them, and you can roll up to 800 pounds. These are really cool on their own, but I want to make them even cooler with a lifting mechanism that will lift both sides at the same time. I'll use 1/2-inch black pipe that I picked up from the big box store for the main axle, and the first step is to clean up all the gunk that comes on it with acetone and steel wool. Once clean, I put a coat of paste wax to prevent rusting, and now I can do some testing for different size bushings that will fit this pipe. If you're not familiar with 3D printing, this program is called a slicer. It's basically the middleman between your design software like Fusion 360 and your 3D printer. It creates the code that your 3D printer can read to create the physical products. This specific slicer is called Bamboo Studio, and it's meant to work seamlessly with Bambu Lab printers. What sets Bamboo Studio apart is the ability to also use it as a design software. So I was able to really easily design these cylinders with different size openings and then label each one all within the slicer. I set them off to print in my Bambu Lab X1 Carbon, which I'll talk more about later on, and in about a half hour I could test fit all these bushings on the pipe. Labeling them in the slicer made them super easy to keep track of. I'll be using a Forstner bit to drill the holes to mount these bushings, so I repeated the same testing process, only this time I put the numbers on the inside of the bushings. All the bushing sizes are sorted out, so I got to work on the mounting brackets that will hold the main axle. After drilling a hole through the sides, I drilled recessed mounting holes through the bottoms and thought the shape was just a little too blocky, so I made them a little nicer looking at the bandsaw. I printed the correct size bushings to match the thickness of these mounting brackets and used CA glue to set them in place. In the past, I've used 5-minute epoxy, but I ran out, so I'm hoping this is going to be strong enough. I think it's going to be fine. To get the position of these brackets, I placed them on the axle, centered them, then screwed them both in place. I tested to see that the axle was rotating nicely, and it was, so I removed it to work on the cam wheels that will lift this whole thing up. I got some more of my workbench scrap and broke this piece down into 2 pieces that were the same thickness. Then used my 6-in-1 jig as a circle cutting jig to make them into 4-inch circles. If you're wondering how I did the math to determine that these needed to be 4-inch circles, I didn't. Before cutting these, I cut out a few different size circles in plywood and tested the rotation on them when drilling an offset hole. 4 inches went up about 1.5 inches with minimal rotation, so I went with 4 inches. Moving right along, I printed some more bushings to match the thickness of this material and glued the bushings into those offset holes I just drilled out. When that dried, I put the cam wheels back on the axle to get the height for the blocks that will lift the whole table. Making sure the cam wheel was in the lowest position where there was the least amount of material between the offset hole and the edge of the circle, I placed a block and marked where it met the bottom of the legs. I ripped it to that width and made sure it was level with the legs so it wouldn't interfere when the table is completely lowered down. This lifter block will need some stabilizers to keep them straight as they move up and down. I'll use some more black pipe for that. So I drilled out holes to fit the same bushings I've been using on all the other parts. And once I got the diameter correct for them, it was easy to alter the height in my drawing to accommodate for the different wood thicknesses I was using and set them off to print. So far, you've just seen me use the 3D printer to make these bushings. But throughout this whole build, I was busy printing tons of other useful stuff. Later, I'll show you guys these dust collection fittings and storage bins that I found on MakerWorld, which is Bambu Lab's user-driven website where people upload their own designs and anyone can print them. There are tons of utilitarian items like dust collection fittings, but there are also really cool looking items like this desk organizer. Simply find what you like, click open in Bambu Studio, and that's it. With the AMS, you can do multicolor prints like this. The printer just knows when to switch colors on its own, so you literally just click and wait for these awesome, useful items to materialize. But not all of my recent prints have been useful. I spent a good couple of weeks experimenting with different filaments to make 3D printed basketballs that actually bounce for my kids. I found the file on MakerWorld, and with the X1C, I was able to easily print literally any filament that I tried. My kids were loving these experiments, and I definitely had fun too. So thanks to Bamboo Lab for sponsoring this video and helping me create all these useful items. I also appreciate all the fun, but now it's time to get back to work on these stabilizer bushings. I glued them into the lifter blocks, and while that's set up, I marked the length that the stabilizer rods needed to be and cut them with a portable bandsaw. I made sure to leave the threads on the ends because I'm going to install these to the underside of the table using floor flanges. Everything seemed like it was sliding smoothly, but I had no idea if this was going to work out or not. I did a few test rotations and it was all very promising. Now everything needs to be permanently fixed. So I took the cam wheels off and counterbored some holes at the drill press, making sure the wider hole fits washers that I have and the through hole fits screws that are meant for metal. I put them back on the axle and rotated the handle so it was at the far end or back of the cabinet. Then, keeping the handle in that position, I rotated the cam wheels so their lowest portions were facing up. Then I locked the components together with screws. I also screwed down the stabilizer rods through the floor flanges and did a billion test turns, and everything was moving very smoothly. I had some serious doubts about this whole mechanism working, so I was really nervous to do the first test lift. Oh my god, I can't believe that works. Okay. I was so proud of myself. I must have lifted it 1,000 times before moving on to the next step. You may have noticed when the casters are deployed, the lifter bar was resting on the floor. Maybe it would be fine to leave it like this, but I don't want it rubbing on the floor when I'm moving the cart around, so I need to figure out a way to bring the lifter bar back up on the stabilizer rods after deployment. I figured springs would be a good idea for this, so I screwed some hooks to the underside of the cabinet and to the top of the lifter block. But when I put the springs on, there was too much slack. These were the only springs and hooks that I had, so I notched the ends of the lifter blocks to create more space, and my son came home right on time to be the first one to test it out. Ready? It's my first time that I'm trying it. It works. It works. And it works. But before I could test it out with some real weight, I permanently attached the lever to the axle with a 90-degree elbow and some thread locker. Okay, now time to test it. Ready? Works like it should when it's empty. Now time to load it up. I can't believe it works. It works so well. Awesome. I was super happy with how it was working, but will it work with all the drawers loaded up and the heavy tools on top? Still very nervous about that, so I try to make everything move as smooth as possible by putting some draw slide tape on the lifter block to eliminate friction from the cam wheels, and I waxed the stabilizer rods. Lifting mechanism is officially done. Time to build the draws. I ripped all the parts to width, which determines the draw height. Then I cut the sides to length, which determines the draw depth. And then using both draw slides and 2 of these sides, I get the length for the fronts and backs, which determines the width of the draw. All parts are cut to size, then they get a groove on one face that will fit the bottom panel. I'm going to use dominoes to join these draw parts together. This is only my second time using dominoes for draws, and I find it to be very quick and easy, especially because I don't have to mark or measure anything. I used the built-in flaps on the domino to reference the ends of the material to make sure everything will line up. I'm using 1/2 inch thick material here, so it's slightly more confusing because I had to use the 4mm bit for 4mm dominoes, but I'm still liking this method. Since I was using the edges as references for the tool, I kept all the parts of the draw the same size at this point. After all the mortises were cut, I took all the back pieces and ripped them right above the groove. This will enable me to slide the bottom in place after assembly, which is what I'll do next. Super simple and straightforward, these boxes come together in no time. I cut all the draw bottoms to size based on the depth of the grooves and knocked down all the edges with a hand plane to make them easier to slide in place. I tacked the bottom to the back with nails and stacked them in the cabinet. From here, I can determine the spacing I want between all the draws using scraps to lift them up on each other. And based on those locations, I mark out where the draw slides will go. To install the slides, I start with a large scrap for the top draw and use that on all the cabinet sides, which ensures they're all going to be the same height. Then I make my way down the cabinet, cutting the scrap each time to get the height of the next set of slides till I get to the bottom. Then to install the draws, I start from the bottom and work my way up. I already have all the spacers that I need when I initially laid everything out, so this goes pretty quick. And I test them out 20 to 30 times before cutting the draw faces to size. For the faces, I felt like getting a little fancy and ordered some maple plywood from Woodworker Source. In fact, all the plywood from the draws were also from Woodworker Source. Besides for all their amazing hardwood that I use on my other projects, they have excellent quality plywood. I was using the pre-finished stuff for all the draw parts. Anyway, I want to have that continuous grain look, so I made all the faces from one panel and taped an arrow to keep all the pieces in order after they're cut. First, I ripped them to their height, then cut them to their length at the miter saw using one of those 3D printed stop blocks that I designed. To make sure the faces are equally spaced from the edges, I use another 3D printed product, 16th inch spacers. After getting them in position, they're clamped to the draw front and screwed from the inside through pre-drilled holes. The open shut them game is even more satisfying now that the fronts are on. I really like the low profile style draw pull that I did on my wall of cabinets in my shop, so I use the same ones here, and it's time to work on the top. This piece of laminate countertop was a cutoff from the cabinet build, so I cut it to length using the track saw and MFT workbench, then glued on some hardwood edge banding to make it look nice. Just a little bit of walnut goes a long way. The top gets screwed on through holes I drilled out in the top stretchers, and the draws go back in. And obviously I need to test to see if I could lift the bench with all the draws installed while I was sitting on it. Super pleased with myself and how it was working. I put on a coat of whatever finish I was almost running out of and cleared the corner where this new tool cart will go. This corner has been bothering me for so long, so it felt so awesome to clean it out. All the chips and dust you see on the floor was just from the drilling done on this project. Drill press dust is the worst, and I'm so excited to get this cabinet into place so I can finally get the dust under control in this area. All cleared out, and the cabinet is ready for its home. I don't think I'll ever get tired of using this lever. This drill press is way heavier than it looks, so I had to wait for my muscle to come home and set it in place. I could handle the sander by myself though. Super strong. I secured the drill press on the countertop so it won't fall over, and even though I have this awesome lever, I thought it would be a good idea to add handles to the sides to make it easier to pull around my shop. I could also use the handles to lift up on each side of the bench in case for some crazy reason I don't want to use my super cool lifting mechanism. Now for dust collection. Always such a problem with these tools, specifically this sander. I had a really hard time finding a fitting that would match this dust port, but now I have a magic robot that can make me anything that I need. So I quickly designed this dust fitting that attaches to a 2.5 inch hose that I can attach to my main dust collection system with a reducer. I couldn't even find the right size fitting for the sander, but fittings like this could cost around $20, and I was able to print it for 85 cents. A quick little test to make sure it works as planned, and we're good. I decided to check Maker World for other dust collection fittings and found this magnetic dust hose adapter. These also need a rubber O-ring for a perfect seal, but 3D printers can print flexible filaments like TPU. So I printed a TPU O-ring faster than I can get a shipment from Amazon that fits seamlessly in the adapter. I'm super excited about this for my drum sander. Oh, and speaking of TPU, Bamboo just came out with a TPU that can go in the AMS. So I just picked some of that up. I'm really excited to try it out on some future projects. Okay, drill press dust collection. I bought this lock line about a year ago, and I've been waiting to build this cabinet to set it up. It's a pretty cool system that's flexible but stays put where you need it. It also has a piece that you use to screw to the base of any surface, and it connects to a 2.5-inch hose that's connected to a reducer just like the sander. This is the real test here. I get the hose as close as possible to the bit, and I'd say that's pretty decent. Let's move on to some storage. At the drill press, I'll obviously store drill bits, and I designed this custom storage that will keep all my drill bits organized. I split up the bin into 4 sections to fill up the whole drawer and created these dovetail tabs so they lock in place. I was inspired by the fast cap drill storage and decided to make some color-coded stickers so I can easily find the right size when I need it, and also easily put them back in the right spots. I dipped the bottom of the drills in some paint that matches the color, and now I know if I'm ever looking for a bit that's a fraction of a 16th, I just need to look at the sections where there's a red color. And when I want to put away my 64th inch bits, I only need to look at the sections with the yellow stickers. I think this is going to be really helpful. I designed this storage to be completely custom for this specific drawer, but I thought it would be really fun to experiment with Gridfinity on this cabinet. If you're not aware, Gridfinity is a modular storage system that's meant to fit any space. All you have to do is print out these grids and install them in your drawer. Then there are literally thousands of Gridfinity bins that you can find on sites like Maker World that people have already designed, like these Forstner bit holders, or you could design your own like I did here. The key to these is that they have these little boxes on the bottom that lock into the grid and everything stays in place. Super neat and organized. I'm definitely going to play around with this more and figure out where else in my shop I can use this system. Now that it's all loaded up, let's see if it's still as easy to lift as it was when it was empty. It wasn't hard at all to do. Okay. It's definitely easier to do with my foot. So fun. Okay, let me talk about it a little bit more. One sec. Okay, so I debated for a while whether or not to put both of these tools on the same cart, because if I'm working with long pieces, one tool might get in the way. But I realized that it won't really happen. Like, let's say I'm working on a long piece here. You can see that the sander is not getting in the way because the table is at this height. This is my normal working height, maybe even higher than this. So it's not really going to be an issue. What it will be an issue is if there's like a magic situation where the bed has to be at this height and the piece is also super wide where it's hitting this part of the sander. If that ever happens, I already demonstrated before how strong I am, I could just move the sander out of the way. But I don't really think that's gonna happen. And also same thing with the sander, having long pieces, the drill press might get in the way, but I could just turn the drill press. And having the wall there, also that's why this cart is movable so that I can do any pieces no matter how long they are. I also had to make this cart movable because it's in the line of my jointer. If I'm milling up anything that's longer than 10 feet or about 10 feet, I'm gonna have to move this out of the way. Or I probably just have to take the sander off. So everything's totally fine, but it's really helpful to have all your carts on wheels. And about those wheels or casters, this whole hand crank situation would not have been possible without these magic casters. The way that they pop up when you lift the workbench is the only reason why this whole situation works. And I just think they're really cool. So I'll drop an affiliate link down below. These are made in the USA and it's a local company. I was chatting with the owner. He seems like a really cool guy. So I just think you guys should check them out, and maybe you guys could figure out different ways to do lifting mechanisms for your benches. I do still feel like the crank is a prototype, so I'm not going to draw plans. And I don't think I'm going to spend any more time trying to perfect it because I'm fine with the way that it works right now, and I just want to move on to some other stuff. But I really want you guys to try and figure out how to make this better, maybe different materials. I did originally think it was going to be a hand crank, but it is more comfortable with my foot. So maybe if I would have cut this a little bit shorter, but then maybe I wouldn't get enough leverage. I don't know, I'm just not sure. And I'm fine with it for now and I'm sticking with it. Maybe I just want you guys to take the reins and figure out how to make this better for your shop and your projects. I'm kind of obsessed with the color-coded storage on the bits here. I think this is really going to change the way that I work. And the Forstner bit organization is just making me so happy. The dust collection, this lock line, the jury is still out. It was a lot better than it was, but it's not perfect. I'm gonna have to test it out a little bit more. Maybe I could get some more of these pieces and extend it to get it closer to the bit, but only time will tell. We'll see. I really didn't think that this was gonna work, and I'm so proud of myself that I got it to work, and it functions amazingly. So, so happy that this corner is nice and organized now. This is just making me really happy. So thank you guys so much for watching, and I'll see you on the next one.
Activate.
Hold on. Hold on. You ready?
Activation.
You ready to go back down? Ready?
Yeah.
And then you're back on solid ground.